Hi everybody, welcome to my video. My name is Achisola Nyala. Today we'll be differentiating polynomials. Yeah, so what is a polynomial? Right here is a polynomial. So this is just an example of a polynomial. What is the property of a polynomial? The nth power decreases as the summation of the terms increases. So we have this nth power, 6, here it's 5, here it's 2, then we have a constant. So this is just the nature of a polynomial. Anyway, we are not here to talk about polynomials. I assume you are well equipped with fundamentals of calculus and all pre-calculus courses. So what is differentiation itself? Like I said in my earlier video, differentiation is nothing but finding a slope. So when we are differentiating a curve, we are simply finding the gradient at a particular point. So if we're differentiating a line, we are simply finding the slope of that line. So differentiation itself is nothing but finding a slope or the gradient of something. Now, let's talk about the notation of differentiation. So this is the notation of differentiation. We simply say dy dx. So when we are differentiating, we are simply doing this in terms of the mathematical notation, dy dx. Now what does this mean? This simply means we are differentiating x. We are differentiating y with respect to x. We're differentiating y with respect to x. Now, it is important to note that y is a polynomial. So y is a polynomial. Y is a polynomial and must be a function of x, at least if we are to differentiate it. Otherwise, if there is no x in the function or in y itself, then the differential of y is always 0. So differentiating a constant will always give us a 0. So at least y should be a function of x if we are to differentiate it. So in other words, we can say this is equivalent to saying differentiating y, which is of course a function of x with respect to x. Now we normally don't use this notation in most of the books and mathematical courses. This is the notation that we are going to use, dy dx. So we are simply differentiating. So now I want to give a definition of differentiation. So this is the notation for differentiation, but what is the definition of differentiation itself? So when we are differentiating, let's say y itself, we are simply doing this. Now this is called the differential coefficient of powers of x. So this is a fundamental formula that I urge you that you paste it in your notebook. So we are going to be using this formula more especially under this topic where we will be differentiating polynomials. So this is the definition of differentiation itself. Now, these are just notation. There's no difference. I can rewrite this whole definition and notation in this form. Let's say I can say dx dt. Now, what does it mean? This simply means I'm differentiating x with respect to t. Now, x should at least be a function of t if I'm going to differentiate. Otherwise, it will be 0. So the formula becomes n into t n minus 1. Now, what does this formula mean? How does this operate? For example, let me give you a practical example. Let's say I have 2x to the 6th power. By now, I hope you know the formula. Now, what does this formula mean? What is my n? N is my nth power. And what is my nth power in this example? It's 6. So I'm going to bring 6 here. But what do I have? I have a 2 already here. And then x. And then what is n minus 1? N minus 1 is 6 minus... sorry for that. Yeah, n minus 1 is... in this case 6 minus 1, which is 5. So I'll have a 5 here. So this is how this formula works. Nothing difficult. Just remember the formula and apply it whenever you actually have polynomials. So this is just the intuition behind differentiation of polynomials. So catch me in the next video where we are going to solve some problems about differentiating polynomials. Thanks for watching. May God bless. Have a good day.